Now I think we've done enough of these to kind of come up with some kind of recipe for how we calculate the roots of complex numbers, okay? So I always encourage you, don't just remember the algorithm, like don't just remember the recipe, get used to like the feel of what's actually going on first. Would you be happy that this is not that bad, okay? But I think we can formalize it in a nice way just to kind of create some clarity here. So don't remember the recipe, think about what's happening here, but we can formalize it to create some clarity. So what's the first thing that we need to do? So let's suppose that we are given a complex number. What do we need to make sure that that complex number is written as? So what form do we need to make sure that complex number is in? It needs to be in a form with a modulus and an argument. Okay, so a form with a modulus and an argument. Okay, so either, I guess you could write it in modulus argument form, but I would go for either Euler or polar form. Okay? And you remember the reason why we did that is because we can then use de Moivre's theorem to find what we're finding with de Moivre's theorem, the base root. Okay? So we'd use de Moivre's theorem to calculate the base root. Right? So if you're calculating the cube root of z like we were here, you would take z and raise it to the power of a third, and you can do that using de Moivre's theorem. That will get you the base root. That will get you this one here. Okay? What's the next thing that you need to do? Would you be happy the next thing you need to do is work out what the spacing is? Like how far apart are the other roots? Once you've got the base root, you need to find out how far apart the other roots are in order to find them. So you need to find the spacing. Remember, how do we find the spacing between the roots?
2 pi divided by how much root we have.
Exactly, 2 pi divided by the number of roots. Okay? And then step 4, we start with the base root and then we just move that many spaces round. So base root plus however many turns we need. So number of required turns. Okay? And that's how you get however many roots you need. Okay, so it's really just a 4-step process. But that's just kind of summarizing exactly what we've been doing.